Now we'll solve some problems on photoelectric effect, Einstein's photoelectric equation. What is the equation? Simple. E equal to K max plus work function, and that reduces to K max equal to HF minus work function. Problem number 1. Light of wavelength 2800 angstrom is falling on potassium, whose work function is 2.3 electron volt. The question is telling us find K max of photoelectrons, find K min of photoelectrons, and find stopping potential, also known as retarding potential. Stopping potential and retarding potential are same. So now, first thing, we need energy of this particular wavelength photon. Energy of this is given by which formula? E is equal to hc by lambda, right? Now h and c may be given in the question, but we don't want to multiply that every time. We remember a simplified formula. E in electron volt is equal to 1242 by lambda in nanometer. This you memorize. H into C in these kind of units will be equal to 1242. Now very easy. So E will become 1242. This is in angstrom. So you want to convert to nanometer. It's 10 to the power minus 10 meter. And nanometer is 10 to the power minus 9 meter. So this will become 280 nanometer. So divide it by 280. And if you do the calculation, you will get 4.4 EV. Now we can find K max. K max is what? K max is E minus work function. E is 4.4 and this is 2.3, all electron volt. So answer comes out to be 2.1 electron volt. As simple as that. What is K min? K min is always 0. If electron wastes the entire energy in coming out to the surface, it has wasted work function, and extra energy it wastes in coming to the surface, it comes out with kinetic energy equal to 0. So K min is always 0. How to find stopping potential? Stopping potential will be equal to K max by E. Remember, K max is E into V naught. So therefore V naught is K max by E. Where is K max? K max is here, 2.1 EV. 2.1 EV. Divide by E. So E gets killed. What is left? 2.1 volt. This is your stopping potential or retarding potential. Problems on photoelectric effect are very, very simple. If you know the concepts and the basics correctly, you can solve any problem. Now we look at one more problem on photoelectric effect. Light of wavelength 3 into 10 to the power minus 7 meter. How many nanometer is that? 300 nanometer, right? So 300 nanometer is falling on a metal surface whose work function is 3 electron volt. We have to find threshold frequency. We have to find K max of photoelectrons, K min of photoelectrons, and stopping potential in volts, right? So how to find threshold frequency? What is threshold frequency? Threshold frequency is work function by Planck's constant, right? Work function is 3 electron volt. What is Planck's constant? It is 6.626 into 10 to the power minus 34 joule second. But we can use the value of Planck's constant in electron volt second and get the answer more quickly. In electron volt second, it is 4.136 into 10 to the power minus 15 electron volt second. Or you can convert electron volt to joules and then use 6.626 into 10 to the power minus 34 joule second. But this is much more simpler here. So 3 by 4 is 0.75. So we can take this as 7.2, right? This will go 10 to the power 15 up. But if I keep one here down, minus 1, I'll get 0.4 there. So then I'll get 7.2 approximately 10 to the power 14 hertz. So this is the threshold frequency. Threshold frequency is nothing but work function by Planck's constant. And Planck's constant typically will be given in the exam. So whatever is given, you can use that. Very easy. Now we have to find Kmax. So for that we need the energy of a photon of this wavelength. So energy of a photon we have seen is given by 1242 by lambda in nanometer. Now this calculation is very easy. 1242 by 300. So all of you can do that. So how much we get? We get 4.14 electron volt. Right? Once you have got energy, you can find Kmax. Kmax is given by E minus work function. E is 4.14 and work function is 3, right? 3 electron volt. So how much you get? 1.14 eV. Kmax is found out and Kmin is easiest thing to find out, right? Kmin is always 0. So Kmin is 0. Now to find out stopping potential. Again that is very easy. It is Kmax by E. Kmax is 1.14 eV divided by E. E gets killed 1.14 volts. Right. So remember this. Threshold frequency is work function by Planck's constant. Kmax is E minus work function. Kmin is always 0. Stopping potential is Kmax by charge of electron. Energy of a photon is given by hc by lambda and h into c in these kind of units where E is in electron volt, lambda is in nanometer, is given by 1242 by lambda in nanometer. Now we look at one more problem on photoelectric effect. This is a question that actually come in IIT JEE. When a beam of 10.6 eV photons are incident on a platinum surface, okay, the intensity is 2 watt per meter square and they are falling on a platinum surface of area 1 into 10 to the power minus 4 meter square. The work function of platinum is 5.6 eV. So when a beam of 10.6 eV photons of intensity 2 watt per meter square fall on a platinum surface of area 1.0 into 10 to the power minus 4 meter square and work function 5.6 eV, 0.53% of the incident photons eject photoelectrons. We have to find the number of photoelectrons emitted per second and their maximum kinetic energy. Actually in JEE it was minimum kinetic energy, that is always 0. So let us find out Kmax. Now Here the intensity is given, the area is given. So we can find out the energy falling per second on the metal surface. Energy will be given by intensity into area. This is energy per unit time, right? So this is intensity into area. If you want, you can write down E by T, energy falling per unit time. Intensity is 2 watt per meter squared, and this is having area of 1 into 10 to the power minus 4 meters square. So we get 2 into 10 to the power minus 4 joules per second. This much energy is falling on the metal surface per second. So how many photons are falling? Energy of each photon will be given by this value, that is the energy of the photon, 10.6 eV. Convert that to joules. Okay. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. This was given in the question, or you can memorize that. This is the charge of electron. Now, if you divide this by this, we can find out the number of photons falling on the metal surface. So, n photons will be equal to 2 into 10 to the power minus 4. This is the total energy falling per second, and each photon is having an energy of 10.6 into 1.6 into 10 to the power minus 19. Out of these photons, 0.53% become photoelectrons. So number of electrons coming out, photoelectrons, will be 0.53% of this, that is 10.6 into 1.6 into 10 to the power minus 19. So this is 20 times. So this will get 20 here. Then this will become 10, right? So you'll have 10 to the power 3. This is 10 to the power minus 19. So we'll get 10 to the power minus 16. 10 to the power minus 16 will go up and become 10 to the power 12. So what we get is 10 to the power 12 divided by 1.6. So this will become 6.25 into 10 to the power 11. These many photoelectrons will get emitted per second. So this is the answer. Second part is even easier, finding Kmax. Kmax we know is given by E minus work function. E is 10.6, work function is 5.6, that will be 5.0 eV. That's all. So when you have got intensity, you have got area, to find the energy per unit time, multiply intensity and area. When you know the energy of each photon and you know the total energy falling per second, total energy falling per second divided by energy of each photon will give you the number of photons. And here they had given this much percentage of the photons become photoelectrons. So therefore we got the number of photoelectrons by that. And finally, this is Einstein's photoelectric equation, Kmax equal to E minus work function. So questions on photoelectric effect are very, very easy. You just need some practice and you can master this very, very easily.